Remember our slope formula is slope is represented by m, y2 minus y1 all over x2 minus x1. People, please sit in the chair. All right, number one. See, I have x1, y1, x2, y2. So my slope equals 6 minus 9 over 1 minus 4. I get negative 3 over negative 3, which equals positive 1, or 1 over 1. Number 2. Cheyenne, sit in the chair, or stand, not on a desk. Yes. Okay, number 2. x1, y1, x2, y2. So my slope equals negative 5 minus negative 1 divided by negative 2 minus negative 4. So negative negative makes it a positive. Negative 5 plus 1 is negative 4. Negative 2 plus 4 is positive 2. Negative 4 over positive 2 is negative 2, or negative 2 over 1. Number 3, slope equals my y2 is negative 5 minus my y1 is negative 1 over my x2, negative 4, minus my x1 is negative 4. Positive positive makes it a plus. Negative 5 plus 1 is negative 4. 4 plus 4 is 0. I cannot divide a number by 0, so this is what kind of slope? That's right, undefined. What kind of line do I have? That's right, a vertical line. Okay, number 4. Quiet down, guys. My slope equals 9 minus 1 over 8 minus 2. I get 8 over 6. Have to simplify this, so I get 4 over 3. They both divide by 2. And that's it. Any questions on how to find slope? You should be experts at this by now. Watch your language. All right, number 5. Rate of change. Rate of change tells on average how a quantity is changing over time. Again, it's pretty much a slope, but we have to interpret it to real life situations. Okay, the graph shows the population growth in China. So here we have the years, and on our y-axis we have the people. Knock it off. Find the rate of change between, on the back, it's been there all year, that's the way we do things in here. Find the rate of change for 1950 to 1975 and 2000 to 2025. Burgess, inside the room. We have to find the slope or the rate of change for 1950 and 1975. By the way, those are our x's, so they're going to be in the denominator. Okay, for 1950 to 1975, so this is actually our x2. So 1975 minus our x1 is going to be 1950, right? Okay. Same with 2000 and 2025. This is our x2, 2025, minus our x1, which is 2000. Okay, now let's look for our y values for between 1950 and 1975. Well, 1950, my y value is 0.55, right? So that's going to be my y1, and 75 is going to be my y2. So I have y2 0.93 minus my y1, which is 0.55. Okay, we're going to need calculator for this one. That's mostly. Okay, some people can do it in their heads. I understand that. 0.93 minus 0.55, I get 0.38 for the numerator, over 1975 minus 1950, 25. Okay, normally we would stop there if they were asking for slope, but they are asking for rate of change. So we need to put this in a real life situation. We need to be able to describe this. So we're going to actually divide this out. 0.38 divided by 25. Okay, my rate of change is 0.0152. If I wanted to put that in a percentage, because population growth is usually done by percentage, multiply it by 100, right? Move your decimal place over 2 times. 1.52%. Okay, so I have 1.52%. All right, let's do the other one. Let's see, this 22,000 is my X1. I'm sorry, my Y1. And 2025, 1.45 is my Y2. So I'm going to have Y2, which is 1.45 minus, yes. Okay, so let's use our calculators so we don't make mistakes. 1.45 minus 1.27, 0.18, and 2025 minus 2000. Again, we're going to have our 25 years. Now there's our slope, but we want to get this to a percentage because we're talking population growth again. So I'm going to take my 1.8 divided by 25, and I get 0.0072. And I'm going to multiply that by 100 to get a percentage because it's population growth. And I get 0.72%. Now they're going to ask us some questions about this. And this is going to be on your final because it's on both of your finals. You got 2 of them, by the way. On the, not next week, but yeah, next week I think are your finals, right? Yeah, we're taking them early. Huh? I'm not sure. I'm not sure what you're saying. All right, B. explaining the meaning of the rate of change in each case. Well, let's see, in each case, we're going to explain that the growth in between 1950 to 1975 was 1.52%, and the growth between 2000 and 2025, please be quiet, was 0.72%. Then they ask us, how are the different rates of change shown on the graph? Well, from here to here, now we're looking at between 1950 and 1975, right? And we're looking at 2000 and 2025. Now, you're supposed to say something about the steepness of those slopes, but it's pretty hard to tell. It's easier to tell with the numbers, the percentages. The slope or the rate was higher between 1950 and 1975, right? So growth line between 1950 to 1975 is steeper. Okay. Now, that would be like, I know there's a lot of gray area here. If you got something close to this as far as explanations, that's fine. You know, maybe say something like, well, earlier it was a higher slope or steeper or something like that. All right, so you're supposed to do that on number 6. Let me do the odds and you can do the evens. How about that? All right, number 7. Okay, number 7. The table shows the population density for the state of Texas in various years. Find the average. Guys, cut it out. Find the average annual rate of change in the population density from 2000 to 2006. Okay, again, this is going to be our X variable, and this is going to be our Y variable. My X1 is going to be 2000, and my X2, 2006. And that means my Y2 is going to be 87.5, and my Y1 is going to be 79.6. So let's put this in our little slope formula and interpret. So I have Y2 is 87.5 minus my Y1 is 79.6 divided by my X2, which is 2006, minus my X1, which is 2000. 87 minus 87.5 minus 79.6 equals 7.9 over, well, 2006 minus 2006. 7.9 divided by 6 gives me 1.32. And if I multiply that by 100, I get 131 or 132 rounded percent growth. Wow, that's pretty high. And it says find the annual rate of change. Well, that's what we did, 132%. That is fantastic. Actually, let's do one more. Let's do number 8. Because you have your own set of problems with it starts with review. You're not going to do the book work, but you have a couple of problems to do. All right, number 8. It says the graph shows the annual coal exports from U.S. mines in millions of short tons. So here's the year. These are X's. The millions of short tons are Y's. Okay. Between 2001 is our X1. And 2002 would be our X2. We need to find the Y values. Let's see, for 2001, we're at 50. That would be my Y1. And my Y2 would be 40. Language. Okay, my slope. Y2, which is 40 minus my Y1, which is 50, all over X2, which is 2002, minus X1, 2001. 40 minus 50, that's right, kids, negative 10. 2002 minus 2001, that's right, kids, 1. So I have a rate of change of negative 10%, right? All right, so, or negative 10 short tons. Okay, how does the rate of change in coal exports from 2005 to 2006 compare to 2001 to 2002? So we got to do it again. There is my X. My X1 is 2005. My X2 is 2006. My Y1 is going to be 50, and my Y2 is going to be 50. Hey, look at that. My rate of change is 0. So from 2005 to 2006, 0 change. So let's answer the question now. How does the rate of change in coal exports from 2005 to 2006 compare to that of 2001, 2002? Well, there's no change in 2005 to 2006. So it's there is no change. from between 2005 to 2006. Yep, let's just use that. And C, explain the meaning of the part of the graph with the slope of 0. There's no change in ton of exports. No change in export quantities. You put just no change, I'll take that. All right, so the rest of the problem is your practice work. 9, 10, 11, 12, and then you have this back. 1, 2, 3. And then you have the back of that, 14, 15, 16, 17, and 18. Questions, comments, concerns? Wonderful. You guys are off on your own.